Section 4, Video 3. Now we're going to graph some inequalities. So let's focus on a unique one here where we have one variable. And when we have one variable, we know it's either going to be vertical or horizontal. So if we looked at it as we normally do, as an equation, we know that this is going to be a vertical line at -4 on the x-axis. But with an inequality, we have a couple things we have to consider. One is, will it be a solid or dotted line? And the line underneath your inequality tells you if it's solid or dotted. If there's a line, then it is going to be solid. If there is no line, it's dotted. So I can go to -4 for x and draw a solid line. The second part is to decide by the inequality, do I shade, or which side do I shade? In this case, since it's a vertical line, we have to decide left or right. And less than on the x-axis is smaller, so we would graph or shade left. And that represents our shaded region. Our next one is a slope-intercept form. So we know the y-intercept is at -2. We know the slope is -1/2, so I'm going to put the negative with the numerator so I know what is affected by the negative. And it's rise over run, so my rise is a -1, so down 1. My run is a +2, so I go to the right 2, and that is our second coordinate. We have to look at the inequality and say, is there a line underneath it? And there is not, so it's dotted. We have to then look at the inequality and see what the symbol is, and it's greater than, so we would shade above. Now there's another way to decide which way to shade if you don't like that, and that is plugging in a coordinate, and the coordinate of choice is 0, 0 because it's easy to plug in. If I plug in the coordinate 0, 0, I get 0 is greater than, and I have -1/2 times 0 minus 2, so I'll get 0 is greater than -2. So it's asking, is 0 greater than -2? And the answer is yes, it is true. And because it's true, we would shade the side that coordinate was on. And here's that coordinate. It is a true statement when you plug it in, so we would shade that side. If we got a false statement, like 0 is less than -2, we would then shade the other side. So that's an alternative way of graphing, or choosing where to shade. The last one, we have to solve or graph an equation that's in standard form. Now, it may cause issue for some, but it is a skill that must be mastered, and that is to make sure you can take an equation and put it into slope-intercept form. If I do that, I get -5y less than or equal to -x minus 15. I divide by -5, and I'm left with y, and because we divided by a negative number, the inequality will change directions. Only when you divide by a negative does that happen. We then have to write two separate fractions. We have -1x over -5x, so I get 1/5 x, and I have to write this one, which gives me a +3. So y-intercept at 3, my rise is a +1, my run is a +5. I look at the inequality, and I see there's a line underneath it, so it's solid. I also see that the inequality is a greater than, so I shade above. Now you can graph this using intercepts, which is to plug in y equals 0 to find the x-intercept, and then you'd find the y-intercept by plugging a 0 in for x, and then you get two coordinates. However, in this particular problem, one of your x-intercepts, I think, is at -15. It's not on your graph, so you run into a little trouble there. But it is an alternative way to come up with 2 points in order to connect. And this ends Section 4, Video 3.